Drake Homework 7 starts off with solving a rational equation. It simplifies to a linear equation. Whenever we have variables in the denominator of our equation, the first thing you're probably going to do is check for restrictions. We know that we cannot divide by 0, so whatever's in the denominator, in this case the w plus 5, can't equal 0. So if we get a solution of negative 5, we then have to say no solution. If it's anything else in the world, then it's okay, but we can't have a negative 5 on the bottom of our fraction. Now, if we do have an equation with a fraction, what we want to do is multiply by the denominator to get rid of the fraction. So we're going to multiply both sides of our equation times the w plus 5 so that we can eliminate that fraction. 1 is going to equal negative 5 times w plus 5. And then we go ahead and solve our equation using our distributive property. Negative 5w minus 25. We're going to add our 25. So 26 equals negative 5w, and then divide. So w is going to equal negative 26 fifths, which is not negative 5, so that is an okay solution. So again, you just want to remind yourself here, if I check for restrictions, if w plus 1 can't equal 0, then w can't equal negative 1. So if I would get an answer of negative 1, I'd have to eliminate that. So in this case, I want to get rid of my fraction, multiply by my denominator of w plus 1, cancels out my fraction. Negative 7 is going to equal negative 4 times w plus 1 then. Using my distributive property, negative 7 equals negative 4w minus 4. Negative times a positive is a negative. I've got to add my 4 to move it over to the other side. So negative 3 equals negative 4w. And then, of course, divide. Negative over a negative is going to be a positive. So positive 3/4 is my answer. It's not a negative 1, so it's okay. And so that would be my solution. So the third one, if I want to solve that one, looking for my restrictions, u cannot equal negative 6, because that would give me 0 on the bottom. So u plus 6 times u plus 6 to cancel out my fraction. 1 equals, using my distributive property, negative 4u minus 24 then. If I add my 24, 25 equals negative 4u, and divide. So u is going to equal negative 25/4, which isn't in my restriction, so is going to be an okay answer. So basically just multiplying by the denominator to get rid of my fraction, and then making sure I look for restrictions on my variable. So the next one, solving a rational equation that's simplified to a linear denominator ax and bx. Again, if I'm thinking about my restrictions, the 3y can't equal 0 and the 5y can't equal 0. I can ignore that one, it doesn't have a variable. Well, with both of those, when I solve them, 0 divided by anything is 0. So y can't equal 0 is going to be my only restriction. So I'm going to solve it, and if I get anything other than 0, I'm all right. So on the ones where you have multiplying by your variable, you're just going to have a restriction of 0, since there's no adding or subtracting in there as far as in your denominator. But in this case, again, I have fractions. I want to get rid of my fractions by multiplying by my common denominator. Since I have a 3y, a 15, and a 5y, 15y would be my common denominator. So I'm going to multiply each term times 15y and do some canceling. Well, the y is going to cancel, and 3 goes into 15 5 times, so 5 times 7 is 35. Here, just the 15 is going to cancel, so 1 times y is 1y, or just y. And then here, the y's will cancel. 5 goes into 15 3 times 6 is 18. So I'm going to subtract my 18 to move it over to the other side. 35 minus 18 would give me 17 equals 1y. And I really don't have to divide by the 1, but I will. So 17 is my answer for y, which is not 0. So I do get the solution of 17. Number 5, again looking at my only restriction is that w cannot equal 0, because again I just have a plain w and a 4w. I want to get rid of my fraction, so I'm going to multiply every term times the least common multiple, which in this case is the 4w. So here the 4w cancels out, I just get the 3. Here just the w cancels out, so 4 times 2 is 8. Here nothing cancels out, so I get 4w. So 3 plus 8 is 11 equals 4w. If I divide by 4, w equals 11/4, which is not 0. So again, I don't have to worry about it being restricted. Number 6 again, the only restriction is that I can't have the 0 in the bottom of the fraction. And so again, I'm going to multiply by my common denominator, so I have to think about 8 and 12. The least common multiple is 24. I also need to have that x, so 24x would be my common denominator. Here the x's are going to cancel out. 8 goes into 24 3 times. I'm going to have to use my distributive property since I have a binomial up there. So I get 3x minus 6. Here 12 goes into 24 2 times. So I have 2x times a negative 1. So minus 2x. And then here nothing's going to, or that was supposed to have an x. Here just the x is going to cancel. And so 1 times 24 should be 24. So combining my like terms, 3x minus 2x is x minus 6 equals 24. If I add my 6, x equals 30, which is not 0, so is okay to have for my answer. So same kind of thing, just here on the restrictions, since there's not a binomial underneath there, it's just one term. Every time you're going to get a 0 when you solve that. So that's the only restriction you're going to have. And then you multiply by your common denominator and solve. 7, 8, and 9 then, same kind of thing. If I'm looking at this one and I'm looking for my common denominator, I want to recognize that 3y minus 9 can be factored into 3 times y minus 3. So when I'm looking for the restriction on my variable, y minus 3 can't equal 0, so y can't equal 3 would be my only restriction. When I multiply by my common denominator, I'm multiplying by the 3y minus 9. In this case, where I don't have the entire denominator, I want to have it in factored form. So 3 times y minus 3. But over here, I could just leave it as a 3y minus 9 because the whole thing's going to cancel out. And same thing here, 3y minus 9. Because if I factor it out, I'm going to end up multiplying it back out again. So why give yourself extra work? So in this case, just recognizing that 3y minus 9 and 3 times y minus 3 are the exact same thing. I'm going to cancel out the y minus 3. So 3 times negative 7 is negative 21. Here I'm going to cancel out the entire denominator, so minus 8. And then here I'm going to multiply that out. Negative 4 times 3y is negative 12y. Negative 4 times negative 9 is a positive 36. So negative 21 equals negative 12y. And then I have to do negative 8 plus 36. So if I do 36 minus 8, I get plus 28. Solving that, I'm going to subtract my 28. So negative 49 equals negative 12y. And then I'm going to divide by negative 12. Doesn't reduce down, but I do have a negative over a negative. So y is going to equal 49/12. My restriction was 3, which it is not. And so that answer is going to be okay. So number 8, if I'm going to solve that one, I want to recognize that 4w minus 24 is the same thing as 4 times w minus 6. So if w minus 6 can't equal 0, then w can't equal 6 would be my only restriction. Multiplying then by my common denominator. Here I want it in factored form, 4 times w minus 6. But over here I can leave it as 4w minus 24. And so on the first part, I'm just going to cancel out the w minus 6 part. That's why I had to factor that one. So 4 times 3 is 12. Here the entire denominator is going to cancel, so I just get the 1. And then here I've got to use my distributive property. So negative 4w plus 24. Negative 1 times negative 24. So 12 is going to equal negative 4w. 1 plus 24 is plus 25 when I combine my like terms. So I'm going to subtract my 25. Negative 13 equals negative 4w and divide. Again, I've got a negative over negative, which is a positive. So w equals 13/4, which again is not the restricted variable, so should be a good answer. Number 9 then. Looking here, this factors into 4 times u plus 5. So if u plus 5 can't equal 0, u can't equal negative 5. So again, multiplying by my common denominator, I'm going to do 4 times u plus 5 on this side that doesn't have all the terms. Over here, 4u plus 20 and 4u plus 20. So the u minus, or u plus 5 cancels out. 4 times negative 2 is negative 8. Here the whole thing cancels out, so I get the 8. And then here I have to use my distributive property. Plus 12u plus 60, multiplying that out. So negative 8 equals 12u plus 68. I've got to subtract my 68 to move that over to the other side. So negative 76 equals 12u, and then I've got to divide by 12. This one I'm going to be able to reduce down because I can divide by 4 and I get negative 19/3. So 76 divided by 4 is 19, and 12 divided by 4 is 3, and so negative 19/3 would be my answer, because that doesn't interfere with my restriction, and so that should be that kind. The next ones, we are simplifying the product and quotient involving square roots of a negative number. Way back many years ago, some guy named Euler decided that the square root of negative 1 would be equal to the imaginary number I. And if he could use an I in for the square root of negative 1, he could do a whole lot more math. Also then, going along with this, if I did the square root of negative 1 squared, squaring a square root would cancel that out, that would equal negative 1. Which means if I square here, I also have to square here. So I squared is going to equal negative 1. So when I'm working with imaginary numbers, anytime I have an I squared, I'm going to substitute a negative 1 in its spot. So I'm going to simplify some expressions that are going to have imaginary numbers. And so first thing I'm going to do is, if there's a negative under the square root, I'm going to take out the I. So I'm going to make this I square root of 56 and I square root of 7. Now, anything in front can be reduced. Anything under the square root can be reduced together. So in this case, since I have an I over an I can cancel those out. 56 divided by 7 gives me 8. So now I have the square root of 8. I want to simplify my square root of 8 because I can simplify the square root of 8. So I'm going to make this the square root of 4 times 2. The square root of 4 is 2, and so 2 square root of 2 is going to be my answer in simplified form. Now in the next one, I'm going to make the first term I square root of 5, and the second one's just going to stay the square root of 2. Again, when I'm multiplying, I would multiply the two outside or front numbers together and the two things under the square roots together, and so I'm going to get I square root of 10. Now if I could simplify the square root of 10, I would, but 10 doesn't have any factors that are perfect squares other than 1. And so I have to leave my answer as I square root of 10 because I can't simplify it any farther than that. Number 11 then, if I'm going to simplify that same kind of thing, I would have I square root of 36 over I square root of 2. The i's are going to cancel. 36 divided by 2 gives me the square root of 18. I want to simplify my radical expression. 9 times 2 is 18, 9 being the biggest perfect square that divides into 18, and so I'm going to end up with 3 square root of 2. The next one here, I'm going to make that I square root of 20 times I square root of 5. I times I would give me I squared. Square root of 20 times 5, 100. Simplifying that, I squared is equal to negative 1. The square root of 100 is 10, so negative 1 times 10 would be negative 10. So number 12, if I'm going to simplify that one, I'm going to have I square root of 10 times I square root of 100 times I square root of 81. Now in this case, I could multiply first, but since my numbers are kind of big, since these are both perfect squares, I might just go ahead and do the square roots first instead of multiplying and having a great big huge number there. So the square root of 100 is 10, that would give me 10i. The square root of 81 is 9, so that would give me 9i. So 10i times 9i would be 90i squared. But again, we have to go ahead and substitute negative 1 in for I squared. And so I get 90 times negative 1, which is negative 90 for that answer. On the next one here, I'm going to have I square root of 90 over the square root of 5. That bottom one didn't have a negative. I've got to leave my I there, but I can reduce my square root down. If I take 90 divided by 5, I'm going to get 18. So I'm going to have I square root of 18. 18 can be simplified, so I would make that 9 times 2. Taking out the square root of 9, I get 3. So I'm going to have 3i square root of 2 for my answer. So simplifying those, I want to take out the I first. And then, like I said, you can either multiply or divide first. Or if they're perfect squares, take the square root out first. It doesn't really matter as long as you're doing the math correctly. 13, 14, and 15, we are multiplying with our complex numbers. When we multiply, we kind of multiply just like we do with our x's, but we have to remember that I squared equals negative 1. So if we do get an I squared, we're going to substitute the negative 1 in and simplify. So these ones we're just foiling. Negative 5 times negative 2 is 10. Negative 5 times 3i is negative 15i. Negative 2i times negative 2 is positive 4i. And then negative 2i times a positive 3i would be negative 6i squared. Here's one of those where I have an I squared, So negative 6 times negative 1 is positive 6. Basically, that I squared just changes its sign, right? So combining my like terms, 10 plus 6 is 16. Negative 15 plus 4i would be negative 11i. Now they tell us to put our numbers in standard form with imaginary numbers. The imaginary number is always on the end. So the real number part goes in front, the imaginary part goes on the end, and that's what standard form is for complex numbers. So number 14, again, I'm going to FOIL that one out. So 6 times 5 is 30. 6 times negative 5i is negative 30i. Negative 4i times 5 is negative 20i. Negative 4i times a negative 5i is a positive 20i squared. Again, we're going to put a negative 1 in there, which makes that a minus 20. Combining our like terms, 30 minus 20 is 10. Negative 30i minus 20i is negative 50i. And my number's in standard form, so 10 minus 50i. And number 15 is the same kind of thing, but I'm not foiling, I'm just using my distributive property, so distributing that out. Negative 3i times 4 would be negative 12i. Negative 3i times negative 2i is positive 6i squared. I squared is equal to negative 1, so I get negative 12i minus 6. However, I don't have my answer in standard form, so I have to make sure I put my answer in standard form since the directions tell me to. So negative 6 minus 12i would be how I would want to have my answer. The next one, it says we're dividing complex numbers. And because I is equal to the square root of negative 1 and we have to rationalize our denominator, what they tell us is we have to get the I out of the denominator of our fraction. If I have a binomial, I'm going to use the conjugate. If it's just a single term with an I, the conjugate is just changing its sign. But the conjugate of 6 minus 6i is going to be 6 plus 6i. And so I have to multiply both the top and the bottom by 6 plus 6i, so that when I FOIL out my conjugate, it cancels my middle term, and I end up with something that doesn't have an imaginary number. Go ahead doing the whole thing, multiplying the top. Negative 3 times 6 is negative 18. Negative 3 times 6i is negative 18i. Negative 3i times 6 is another negative 18i. And negative 3i times a positive 6i is a negative 18i squared. Substituting in our negative 1, that makes a plus 18. Hey, that one has a negative 18 and a positive 18, so I'm just going to have a minus 36i when I combine the negative 18i and the negative 18i that's in the middle. On the bottom, 6 times 6 is 36. We're going to have a plus 36i and a minus 36i, and then I'm going to have a minus 36i squared. I squared is negative 1, so that makes that plus 36, and 36 plus 36 is 72. And so now I'm going to simplify that. Since it's a fraction, I'm just going to put the I behind it. So negative 36 over 72 would be negative 1/2, and the I goes behind it. So my answer here is going to be negative 1/2i. The next one, if I multiply by the conjugate there, I'm going to use 4 plus I. It's always the conjugate of the denominator, so the same terms with the opposite sign. Multiplying it out on the top, I get negative 12i, then I get negative 3i squared. We know that's negative 1, so negative times a negative makes it a positive 3 minus 12i, switching it around so that it's in standard form. On the bottom, 4 times 4 is 16. I'm going to get a positive 4i and a negative 4i for my middle terms, which will cancel out. And then I'm going to get a negative I squared. I'm going to put a negative 1 in there, and a negative times a negative makes it a positive. So I get 16 plus 1, which is 17. So in standard form, they're just going to make these two separate fractions. And so I'm going to have 3/17 minus 12/17 I. And of course, if I could simplify my fractions, I would, but I couldn't, so I didn't. One more of those. So number 18, my conjugate. I'm going to use negative 5 plus 6i. Same two terms, just the sign in front of the imaginary part changes, not on the real number part. So foiling, negative 3 times negative 5 is 15. Then I'm going to have a minus 18i, and on the inside a minus 30i. And then my last, a positive 36i squared. That's going to be negative 1, so I'm going to have a minus 36. Whoa, where did my board go? Let's move that down, back down to where we were at. Had my pen on the board too long. And so combining my like terms, of course I want to do the real number part first. So negative 36 plus 15 would give me negative 21. And then negative 18i minus 30i would be negative 48i. Gosh darn, my board moved again. Okay, on the bottom, see if my board behaves. Negative 5 times negative 5 is 25. My outside product is negative 30i. My inside product is positive 30i. Those are opposites, so cancel. Negative 6i times a positive 6i is a negative 36i squared. So when I put in my negative 1, I get a positive 36. So 25 plus 36 would be 61. So on the bottom of each of my fractions, I'm going to have a 61. If I could reduce those fractions, I would. I don't think I can, but I'm going to double check quickly. Nope, I can't. And so my answer is going to be negative 21 over 61 minus 48 over 61, and the I goes behind that so that it's in standard form. The last one's on this page, simplifying an I value, a complex number that has a higher exponent. We know that I squared is equal to negative 1. So if we can rewrite it in terms of I squared, we can put the negative 1 in its place. So what I'm going to do basically is take the 2 and divide it into the 21 using long division. 2 goes into 2 once, then I bring down my 1, 2 goes into 1 0 times, so I end up having a remainder of 1. If I have I squared to the 10th power, that would be 20, but I have an extra 1 because I need to have 21. So that's how I'm going to rewrite it. I squared to the 10th would be 20 of my i's times an extra I to get to 21. I'm then going to put negative 1 in for my I squared. Well, negative 1 to the 10th power, negative 1 times negative 1 times negative 1 all the way 10 times, since it's even, gives me a positive 1. 1 times that I have gives me just a plain old I. So I to the 21st power simplifies just into an I. Now, if I have I to the 52nd power, if I think about how many times does 2 go into 52, 2 goes into 52 26 times. No extra thing left over because 52 was even. 2 times 26 is 52. So again, I squared is negative 1, and negative 1 to the 26th power, since that's an even exponent, is going to give me an answer of positive 1. And if I slide up for that last one here, if I have I to the 27th power then, again, I'm thinking about, well, how many times does 2 go into 27? It goes in there 13 times. 2 times 13 is 26, so I need to have that extra I, which would give me 27. So, negative 1 to the 13th times I. Well, this time I have an odd exponent. Negative 1 to the 13th power stays negative since it's odd, so negative 1 times I gives me negative I for my answer. So there's really only 4 possible answers once I have it simplified. Either I'm going to have an I or a negative I, or a 1 or a negative 1. Anything else, something's wrong with your calculations.